Hey Geometries, this is Mr. Bloom, and we're doing notes for section 4.6. And on section 4.6, we're looking, I can use the hypotenuse leg congruence theorem to prove that two right triangles are congruent. Now, in order to get this done, part of this, I wanted to have a pointer with you all, so I'm going to get myself a pointer. And, well, let's make a pointer this way. I hope that'll work. So the legs of a right triangle are the two sides that touch the right angle. So first of all, this is the leg, that's the leg. So let's talk about legs. Okay, these are legs. Okay, this is my right angle right there. My right angle. And that is the hypotenuse. Let's use that. Okay, so now the hypotenuse is the longest side in this triangle and is opposite the right angle. So we kind of get this idea of opposite. The opposite the right angle is right over there. That's why that's the hypotenuse. All right, so we got this idea of right triangle, and the hypotenuse leg theorem states that if the hypotenuse and one pair of corresponding legs are congruent on the right triangle, then the triangles are congruent. So if I have a right triangle and another right triangle, that's step one. I have to have the triangles must be right triangles, and a leg that corresponds to the other leg congruent, along with the hypotenuse here and here congruent, then I can talk about the two triangles being congruent. But keeping in mind, since triangle PQR and triangle XYZ are right triangles, aka they have right angles, then, and I also have that, first of all, PR and XY, PR and XY, oopsie, not Y, XZ. Somebody got carried away and was really proud of his stuff. So XZ, let's make that change. PR and XZ are hypotenuses that are congruent. PQ and XY are legs that are congruent. Then I can state that triangles are congruent. Okay, that these two triangles, PQR and XYZ, are congruent by the hypotenuse leg congruence theorem. Now, note, this is the only case in which we can get what appears to be side-side angle, or ASS. By the way, we wouldn't have ASS written in the math book, and just FYI. Okay, the angle must be a right angle, just like we talked about. It's got to be a right triangle. Okay, and we're going to discuss why in this case side angle works. It is really side, where the third sides must be congruent from the Pythagorean theorem. Recall the Pythagorean theorem, which is a squared plus b squared equals c squared. If I have a right triangle, and we have a right triangle, and I have a hypotenuse, and I have a leg, and I have another leg, I can find the third leg using Pythagorean theorem. Okay, now at a risk of repeating myself, note, this is the only case in which we can get what appears to be side-side angle, or ASS. You won't see ASS in a math book. Please think about it. The angle must be a right angle. Ooh, the angle must be a right angle. Discuss why in this case side-side angle works. It's really about side, where the third sides must be congruent from the Pythagorean theorem. Hey, oops, Pythagorean theorem a squared plus b squared equals c squared. Gosh, I wonder where I heard that before. Anyways, let's move on. So now, these triangles, if these two triangles were to be congruent, okay, Step 1, triangles must be right angles. If they don't have right angles, I cannot use HL. Step 2, the triangles must have corresponding hypotenuse lengths congruent. Okay, the triangles corresponding hypotenuse lengths. Okay, and then step 3, the triangles must have corresponding legs congruent. Corresponding legs congruent. Then I can use HL. But if I don't have those 3 things, I cannot use HL. Now, are the 2 triangles congruent? Here's the thing. I have my hypotenuse. How I was able to find it? It's opposite the right angle. Yeah, the hypotenuse is congruent. That was step 1. First, right triangle. I got right angles, so that I got right triangles. Step 2, hypotenuse. Step 3, legs. Do I have legs? Okay, do I have legs? I've got a leg of 6 on a leg of 6. Boy, those look pretty darn cool. And correspondingly, right, if I talk about triangle A, go along the thing that doesn't have anything, B, C, okay, D, go along with nothing marked, D, E, F. Okay, so yes, A, C, B, or well, I want A, B, C, D, E, F. Okay, I've got them. Corresponding sides are linked up. Now I want you to give number 2 a try. Is it a right triangle? Are the hypotenuses marked? Are the legs marked? Or can you find them? Go. All right, now, hypotenuse. Well, first of all, right angle because vertical angles. This and this correspondingly, this is my hypotenuse, looking pretty good. All right, and so I have triangle MON, MON going that way, to MLP going that way, corresponding sides being lined up. So yes, triangles by HL congruence. And this is by HL congruence. So yeah, I can use those on those 2 so far. Now in 3, step 1, are they right triangles? No, they aren't. And I have people going, well, they look like they're right angles. Do they have the marking that shows the sides are perpendicular? So there should be a marking right here. So there is no marking. So I cannot say, no, not enough information. Triangles do not have right angles. I'm going to stop dead in the water. It seems to be that the sides, the hypotenuse and the leg, could be lined up to be HL, but because there's no right angle, I can't do anything more than answer it the way I did in 3. In problem 4, step 1, right angles, check. Step 2, hippopotamuses. Hey, I totally can show that RV is congruent to RV because of reflexive. Okay. Step 3, do I have legs that correspond? I sure do. Okay, so now I got to be looking at this and say, yes, triangle RTV, I'm going RTV is congruent to RXV, and I'm happy by HL congruence. Okay, that's the thing and we're doing. We got to go right angle, hypotenuse, leg. If I'm missing one of those things, I got to find it. If I can find it using my brain with the stuff I know, great. But if I can't make it up, and I can't say it looks like it. I got to have facts to back up my reasoning. Now, HL theorem and systems of equations. Systems of equations. Ding, 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 ding. That's why we did this stuff yesterday on getting ready, our pre-work on section 4.6 to do systems of equations. Okay, so if we're going to use HL, all right, we got to keep in mind, we got to be thinking systems of equations. They want to be, for what values of x and y are the triangles congruent? Now, keep in mind, you solve by substitution. That's what we're going to do. But our first thing is to have a relationship. So I've got my hypotenuse. opposite the right angle. I've got my hypotenuse, opposite the right angle. So I know that I've got x is equal to 2y. Now, I have corresponding legs, okay? Well, these two legs have to be the same in order for this to work. So now I have a system of equations. I have two equations to solve for two unknowns. So I'm going to use, like they hinted, use substitution, and I'm going to substitute where I see x, 2y. So I'm going to get that done. I got my 2y in there. Then I evaluate. So I've got 2y minus y, which is y minus 4, is equal to 3. And keep in mind, I'm just going to make sure people see what I did. I had a y there. I subtracted from over here, and I have y minus 4 equal 3. I am now going to add 4 to both sides. So y is equal to 7. So I fully know y is 7. I'm going to take the easier of the two equations, x equal 2y, x equal 2y, take x equal 2y. That's the easier of the two equations. Oh, x equal 2y. I'm going to take that, plug in 7 in there. Okay, I think I even started up here, but I took this and plugged in 7. So I brought this along, put that together, and we have x is 14. So now I'm going to clearly write this thing here and make sure I know x is 14 and y is 7. Now, anytime we do a problem like this, we always have a second one to practice. I would like you to shut me off and practice the one that's to our right. Please shut it down and see if you can do it by yourself. Did you shut me off? Please shut me off. Okay, welcome back. All right, so now again, I got a right triangle, right triangle. I got a chance to move and use HL. The side opposite the right angle is the hypotenuse. The side opposite the right angle is the hypotenuse. And I have a corresponding leg that has a relationship on it. All right. Now, I am going to set this up, this relationship up, if I can find where I set up this relationship, because apparently I didn't do it anywhere. Okay, good. I was getting worried I didn't do it at all. So I first have y plus 5 equals 2y minus x. And all I'm doing right now is making sure the relationships I said were the ones that I wrote down. Now, here's the thing. These look really hard, but in investigating this, I'm really kind of happy because I just noticed if I take x away from this and I take x away from this, and I'm just going to double check. I got both x's in there. So I'm going to solve this for y because that makes it easier for what I'm going to do next. So I solve for y, and I take away x on both sides, and I get y equals 7. Well, if y is 7, I take this other equation, and where I see y here and here, I'm going to place the value of 7. So I'm going to pop those in. See, I'm using this equation, and concert with this, and I'm going to pop them in and get it done. So I now evaluate 7 plus 5, which is 12, 2 times 7, which is 14. Okay, I got to regroup these. Group, and I'm going to lock, allow, move, and rotation. All right, so I'm going to get over here, and I've got this over here. So I got this. I'm going to subtract 14 from both sides, and I get negative 2. I'm going to divide by negative 1, or multiply by negative 1. X is 2. And again, I've got my answer right here, clearly stated, and I'll probably even box it in. I hope you were able to get that one done and didn't throw you for a loop. Okay. Now, writing a proof using HL. This is so stressful, it's a proof. Well, is it? Let's think about it. What's the first thing that we're going to do when we write down a proof? Well, we're going to take the information provided, okay? And we are going to take and put the given down. So the given hops in there right away, and somebody forgot to put in a couple things apparently. So we need those put in. Okay, so I've got segment BE bisects segment AD at C. Okay, segment BE is cutting this one in half. So I can prove those by definition of bisector. So I got to use that definition of bisect. Okay. Oh, wait, those are hypotenuses because they're opposite the right angle. So, and I got legs. Those are legs. Those are legs. I can use HL here to prove these triangles. But wait, this is not quite a right angle yet because they have these two statements about them. And people, well, what's the big deal? Those two statements would require me to talk about perpendicular lines make right angles, and all right angles are congruent. So we're going to do the given, and we're going to talk about our two sides being congruent because of definition of bisector. But now I've got the perpendicular two-step. This relationship, because of these, it requires me to talk about the perpendicular lines that make these two right angles. Okay, and then I can talk about them being right triangles. Okay, so now ABC and DEC are right angles. Okay, because they're right angles, I know that by definition of perpendicular lines. Now, because they're right angles, they're congruent. So all right angles are congruent. Okay. Now, after I say that, I'm going to define those as right triangles. So I know that triangle ABC and triangle DEC are right triangles. Okay, and that's by definition of right triangles. Now, because they're right triangles and I've got right angles, I can totally use HL. So now I'm going to close it out and say triangle ABC is congruent to triangle DEC. Triangle ABC is congruent to DEC. I'm just checking the order because of HL congruence. Okay, and that finishes out my proof. I'm all done with that. Okay, and I hope this stuff is making sense. Let's just double check to see where we're going. Oh, it's our 4-6B assignment, or 4-6 assignment. So, I had that. Just want to make sure that that all comes up and you guys are able to see what's going on. So now, I want to make sure it's clear. If you've got questions, you have to seek out assistance from your local geometry teacher. Okay, you know, the ones you go see every day. And ask the questions that you have or the things you wonder. And again, just like always, I'm Mr. Bloom and you're not. Have yourselves a great day, folks.